Less than 12 hours ago, a document supposedly leaked that said combining large language models with quantum chips has jumped the AGI timeline forward by an entire decade. Now look, we are living right on the edge of two massive technological revolutions, quantum computing and artificial intelligence. They could solve some of humanity's greatest challenges, but they also bring a totally new kind of threat, one that moves in silence and is, believe it or not, already happening.
This isn't some future prediction. It's about a new kind of data heist that's happening right now. Your encrypted emails, your company's biggest trade secrets, even top-level government intelligence, all of it could be sitting on some adversary server as we speak, just captured and waiting for a key that technically doesn't even exist yet.
And this is not science fiction, not at all. A recent security analysis just lays it out plain and simple. The game has changed. The quantum threat isn't something that's years away. The attacks, the groundwork, that's all happening now, which makes this a very urgent present-day crisis.
Yeah, we spend so much time worrying about what these incredibly powerful machines are going to be able to do. But what if the real story, the one that researchers are only now starting to uncover, is about their own hidden weaknesses? We are definitely going to get to that.
Okay, so first we really need to get our heads around the fundamental problem here. The entire foundation of, well, pretty much all of our digital security is about to face a storm like we have never seen before.
So here's the crucial thing to understand. The digital locks that protect everything, from your bank account to national secrets, they're all built on math problems that are just way too hard for today's computers to solve. But a quantum computer running something called Shor's algorithm, well, that's like a master safecracker who can just listen to the tumblers and pop open any lock in seconds. It's not about brute force, it's about knowing the single right answer almost instantly.
And this is where the threat goes from being a future problem to a today problem. See, the strategy isn't to break the locks right now, it's to steal all the locked boxes and just wait for that master key to be built.
Security folks have a name for this: Harvest Now, Decrypt Later, or HNDL. It means that nation-states, cybercriminals, you name it, are just sucking up massive amounts of encrypted data as we speak. They can't read it, yet, but they're stockpiling it, betting that in a few years, a quantum computer is going to crack it all wide open.
Now, what's really fascinating here is how this frames the problem. Just think about it. How long does a secret need to stay secret? A company's trade secrets? Maybe 20 years. Your personal medical records? Probably 50 plus. State secrets? We could be talking 100 years or more. So if a quantum computer can break today's encryption in, say, 10 or 15 years, then any data that's harvested today that needs to be secret for longer than that, well, it's already compromised. The clock is already ticking.
And just when all of that seems bad enough, a new piece enters the game, and it acts as this massive threat multiplier, the convergence of quantum and AI.
See, when you combine these two technologies, you don't just add their threats, you multiply them. I mean, imagine an AI powered by a quantum processor that can not only break any encryption, but also write its own malware, create its own phishing attacks, and even cover its own tracks. We're talking about a cyber weapon so powerful and so autonomous that it operates completely beyond any meaningful human supervision.
And in this frantic race to build these ever more powerful systems, we might be overlooking one crucial detail. And that brings us back to that question I asked you at the beginning. We're terrified of the power of quantum computers, but maybe we should be looking at their fragility. There's this common assumption that these machines, born from these really esoteric laws of physics, are somehow above the dirty business of regular hacking, that they're just these flawless, unbreachable computational fortresses.
Yeah, that assumption is dangerously wrong. The latest research is showing that these early-stage quantum computers are actually riddled with vulnerabilities, not just in theory, but in practice. These aren't just potential flaws. They are actual security holes that have already been demonstrated in labs.
And this illustrates the point perfectly. I mean, researchers have shown they can literally shout at a quantum computer's memory to flip its quantum bits, the qubits, and corrupt the entire calculation. Others have been able to listen in on the faint electronic whispers of the machine and actually steal the secrets that it's processing. These machines are not fortresses. They have backdoors.
So, okay, the situation seems pretty dire. A crypto apocalypse is on the horizon, it's getting supercharged by AI, and the quantum machines themselves are vulnerable. But this isn't the end of the story. The race to build the shield is every bit as intense as the race to build the sword. The #1 defense is a whole new generation of encryption called Post-Quantum Cryptography, or PQC.
And the beauty of PQC is that it runs on the computers we already have. But it's based on totally different types of math problems that, as far as we know, are hard for both classical and quantum computers to solve. The U.S. government standards body, NIST, has already signed off on the first batch of these new algorithms.
So how does this actually translate into the real world? Well, for big organizations, the path forward is clear, even if it's a huge challenge. It starts with a crypto inventory, basically finding every single piece of code that's vulnerable. And from there, it's a multi-year slog of planning, testing, and migrating over to these new PQC standards. It's a massive shift, and the experts say the time to start was yesterday.
But here's the real twist in the story. The same AI that is such a massive threat when it's combined with quantum attacks is also proving to be our most powerful ally in quantum defense. It is literally playing for both teams.
First off, AI is helping us build better quantum computers in the first place. See, today's machines are incredibly noisy, and they make a lot of errors. But it turns out you can train deep learning models to predict and cancel out that noise in real time. This quantum error mitigation, as they call it, makes the hardware way more stable, which is absolutely essential for developing our defenses.
And second, AI is being developed to act as a watchdog. Researchers are building what they're calling a quantum ethical sentinel. It's basically an AI system designed to monitor all the complex stuff happening inside a quantum computer, forecast potential risks, and flag any behavior that might signal it's being misused. It's like an AI cop walking the quantum beat.
So in the end, that's really what this all boils down to. It's a high-stakes, invisible arms race between those building quantum weapons and those who are forging quantum shields. And what's wild is that both sides are using artificial intelligence to try and get an edge. This isn't some future war. It's a conflict whose opening battles are already being fought, right now, in labs and on servers all around the world.
The question of who wins this race is going to define security for the entire next century. But that brings us to our question for you today. When you think about the long-term nature of that harvest now, decrypt later threat, which sector do you think is in the most danger? Is it healthcare, finance, government, or maybe something else entirely? Let us know what you think in the comments below.